तूने क्यों ना समझा।
Good afternoon to all of you.
Good afternoon.
You done in last class. Planarity done. Yes. Planarity done.
Yes, ma'am.
Yes, ma'am.
Okay. I gave you one exercise K5 and K33. Check whether these are planar or not. Can you say about it? Planar, complete graph, complete bipartite graph. Are these planar?
Ma'am, K5 is planar.
K5 is planar. Can you draw it in plane? Yes. Just try it. One more edge will be there, right? What about this to this, right? So where should I draw this? Here or here? Is it planar? No,
No,
we
ma'am.
can't pass here, right? Here, again crossing. Any other way? No. So this edge we cannot draw without crossing. Okay, so this is non-planar. Similarly, K33 is also non-planar. Okay, so Kn, wherever n is at least 5, this is non-planar. Understood? Yes. And K33, or you can just say Kr, S, where R and S both are at least 3. For example, we can just take K5 is subgraph of this graph. What can you say about this graph? Is it planar, non-planar, or what? Yes? We have
Not
only
planar.
this much information that K5 is the subgraph of G. What can you say about this bigger graph, this G? Is it planar, non-planar? Yeah,
Not planar.
non-planar. Why is it
Not
so?
planar. N is
Why is it
greater than
so?
5. Ma'am,
Not
N is
saying
greater
this
than
is.
5.
I'm not saying this is complete graph. This may be any graph which contains K5. Yeah, there exists some graph which contains K5, K6, so which are not complete. This may not be Kn. Still, it is non-planar. Why is it so?
Ma'am,
Yes,
because that K5 part will not be planar.
yes. K5 part, the smaller part, if we are not able to draw, then how we will draw this one in a plane, right? So any graph, if H is the subgraph of G, and we are sure about H is non-planar, then you can say G is also non-planar. Understood? Similarly, what about K4 3, K4 comma 3? It will be non-planar. K33 present in this.
Ma'am, if it is given K4 is subgraph of G, then how it tell that it is planar or not planar, non-planar?
That will depend. If you are able to draw in a plane, if K4 is given, then you can't say. It can be planar, it may not be planar. If you are able to draw as a plane graph, then it's planar, otherwise not. Means if any planar graph is given, that is the subgraph of bigger graph, and it is asking about the bigger graph, whether it is planar or not, we can't say. It can be planar, it can be non-planar. Okay. But if you know that there is some subgraph, H is the subgraph of G, and the bigger one is planar. Then what can you say about its subgraph?
It is also planar?
It will be also planar, right? The
Yes,
bigger
ma'am.
part you are able to draw, then obviously smaller part will be easy to draw in plane, right? And smaller, if it is given as non-planar, then bigger will be non-planar, right? I hope it is clear.
Yes, ma'am.
Okay. What about this one? Are you started matrices or not?
No, ma'am.
No. Okay. Um, so we'll write two types of matrices. We'll form two types of matrices for a loopless graph. One is adjacency matrix. This is represented by AG, and another is incidence matrix represented by MG. Okay, adjacency means whenever two vertices are adjacent. Okay, that is this adjacency word is coming from adjacent vertices. Okay. So G, the graph is loopless graph. Loopless means loop are not present. It may have the multi edges. Okay, either it is multi graph or it is simple graph, but not pseudo graph. Clear? With the vertex set, there are n vertices and m edges. Then you can find AG, that is adjacency matrix. Adjacency matrix will have order n by n. Okay, this n is coming from number of vertices. Okay, clear? And where ijth element will be given by the number of edges with between vi and vj, or you can just say with endpoint vi and vj. Suppose this is ith vertex and this is jth vertex, then the number of edges, if there are three edges, then a I j will be 3. If two edges, then it will be 2. Clear? For example, if you take this graph A, B, C, then adjacency matrix will be, tell me the order of adjacency matrix.
3
Order
into
of
3.
adjacency matrix, it is 3 by 3, right? Number of vertices, that is coming from order of the graph, n by n, 3 by 3. Now you can write, for simplicity, to make it simple, you can write ABC over here. Okay, any order you can write, whatever the order here, you can write over here A, B, C. Okay. Now, how many edges are there with endpoint A and A? That is, how many edges between A and A? First vertex, right? First vertex, second vertex, first vertex, third vertex. How many are present between A and B? Number of edges between vertices A and B.
3.
3. So second A, B. So this one will be 3. How many vertices are present between A and B?
Ma'am, not audible.
How many edges are present between A and C?
1.
1. What about B and A? Take this vertex and this vertex. B and A,
3.
3. Right? That will be same as this one. A and B and B. That means AIJ and B, AJI will be same, right? Because number of edges between ith vertex and jth vertex will be same as number of edges between jth vertex and ith vertex, right? Yeah, B and C, B and B, there is no loop, that's why 0. And this graph is loopless, that's why all the diagonal entry will be 0, 0, 0. B and C, yes. How many
1.
edges? 1, right? C and A, same as A and C, that is this vertex, this number will be here, right? C and B, 1, C and C, 0. Now, if you look at this one, this is your adjacency matrix, and this row, the first row is same as first column, second row is same as second column, third row is same as third column. Means to say, Aij, the entry Aij, ijth entry is same as jith entry. Clear? Yes? Means to say this is symmetric matrix, and this will be always symmetric matrix AG. Okay, adjacency matrix is always symmetric matrix with diagonal 0. All the diagonal entries are 0. Is there any doubt?
No, ma'am.
No. Okay, then find the adjacency matrix for this one, for this graph. Here vertex set is xyz, wxyz, and axes are a, b, c, d, e. Draw it and tell me. Order of matrix will be
4 cross 4.
4 cross 4. You can take WXYZ, 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 or XYZ, WXYZ, or any other order. Whatever order you are taking over here, you can take here, right? This will be your 4 cross 4. So which order you are taking?
WXYZ.
WXYZ, okay. So between all the diagonal entry will be 0, 0, 0, right?
Yes, ma'am.
What
Yes, ma'am.
about W and X? How many edges are present between W and X?
1.
A12 will be 1. How many
1.
between W and Y?
1.
W and Y, 1. W and Z, there is no S,
0.
0. And this row will be same as this column. So you can copy it, right? X2, X0, X2, Y, X2, Y,
2.
2, right? X2, Z, 0. This is same as this column. So you can write 2, 2, 0, 0, right? But what Y to Y, 0, Y to Z, Y to Z, there is 1, and Z to Y again 1, right? 0. So this is your adjacency matrix. Okay, clear?
1.
Yes, ma'am.
Yeah. One more concept is the degree concept. Or before degree, let me give you incident concept. What is when you say an edge and a vertex are incident? Means to say, whenever you are talking about two vertices, they can be neighbors, means they can be adjacent, right? A, B. These two vertices are related, means there is an edge between them. Clear? We say these are adjacent, right? Adjacent means adjacent two vertices. Okay. Whenever we say incident means we are talking about a vertex and an edge. Okay. Okay. If E is an edge with endpoint A and B, then we say E is incident with its endpoints. Means A and E are incident. Okay. And B and E are incident. Clear?
Yes, ma'am.
So,
Ma'am, one
so
second. I can't hear anything on
how
network issue.
many edges are incident with vertex C?
Ma'am, please repeat
Yes.
once again the incidence matrix.
Incident means whenever E is an edge with endpoint A and B, then we say this edge is incident with its endpoint. That means A and E are incident, edge E and vertex A are incident. Okay, or you can say E is incident with A is incident with E. Okay, and same with B. E is incident with B. Okay, an edge will be incident with the vertex if this vertex is some endpoint of E. Clear?
Clear, ma'am.
Okay, so how many edges are incident with this vertex C in this graph?
2.
2.
Two, right? With B,
3.
4.
4. 4.
right? Three over here and one over here. With A,
4.
3.
again four, right? Four edges are incident with this vertex. and 4 edges are with this vertex. These number of edges incident with this vertex, these gives you degree of the vertex. Okay, so we say the number of edges incident with the vertex is giving you the degree is defined as degree. So degree of C is 2, degree of B is 4, degree of A is 4. Understood? The number of incident edges. Clear? The degree of a vertex V is the number of incident edges with vertex V. Okay? Count all the edges which are incident with V. That is giving you degree. It is denoted by degree DEG of V. Okay? Degree of vertex. Or you can also denote when you have more than one graph, degree of V in graph G, degree of V in graph H, and so on. Okay? Either this one or you can simply write degree of V. Okay? So degree of C is 2, degree of B is 4, degree of A is 4. Clear? And here this is the incident definition. If a vertex V is an endpoint of an HE, then we say, what we say, V and E are incident. Okay, V is incident with E or E is incident with V. Is that clear? Yes?
Yes, ma'am.
Hmm? Now, in this graph, what can I say about degree of B? Degree of B is 4, right? And if graph is not given, only adjacency matrix is given, then you can talk about its degree, degree of vertices. So degree of B will be the sum of all the element in this row. Okay, degree of A will be sum of all the entries in this row. Degree of C will be sum of all the entries in this row. Okay, so the corresponding row you pick up and take sum of all the elements. Okay, all the entries in that corresponding row. 3 plus 1 giving you 4. 4 is the degree of A, and 3 plus again 1 plus 0, that is giving you 4. Again degree of B. 1 plus 1 plus 0, that is 2. 2 is the degree of C. Similarly, here you can check degree of X. Degree of X from this matrix, it is coming as 3. What can you say about this graph? Is it 3 or 4? 3. Right? Same Y. Degree of Y is 4. Right? Degree of W 2. Right? Here
Yes, ma'am.
3, here 1. So, in general, you can say in the adjacency matrix, degree of ith vertex is the sum of all the entries in ith row. Okay? So, Aij, j is running from 1 to n, means you run our column. Right? You take sum of all the entries in that row. That is giving you the degree of Vi. Then, understood?
Yes, ma'am.
Okay. Now come to incident matrix. See, adjacency matrix was we were counting this number of edges between the vertex, ith vertex and jth vertex. Incidence matrix is corresponding to an edge and a vertex. So degrees, order of this matrix will be n by m. M is the size, n is the order of the graph. Clear? So here you have mg denoted by mg, incidence matrix, mij, n by m. So for this graph, what is the order of matrix? Incidence matrix?
3 cross 5.
3 cross 5,
And th-
right? It will be 3 cross 5 because number of 3 cross 5, and yeah, here you can write A, B, C, the vertices. Here you can write edges. So E1, E2, E3, E4, E5. Clear? So here you can write E1, E2, E3, E4, E5. E5. Got it? So A with E1. What you will check whether A is the endpoint of this edge or not.
no, ma'am.
No. So you will put 0. If endpoint, you will put 1. So this is incidence matrix will be giving you 0, 1 matrix that consists of zeros and 1. What about A and A2?
One.
1.
1. A and A3? 1.
One.
1. E5? 1.
1, 1,
With
1.
B?
One.
1, 1, 1, 1. 5,
Zero.
0. What about C?
One.
And
1,
in E1,
Zero. Zero. One.
0, 0,
0,
0, 1.
0,
Zero.
0, 1.
1.
Whenever the vertex is endpoint of this corresponding edge, then you put 1, otherwise 0. Clear?
Yes, ma'am.
The same incidence matrix you find for this graph. Here these are vertices, here will be edges. What is the order of that matrix? Incidence matrix?
Four
4
cross
cross
five.
5.
4 cross 5.
5. Right? You take WXY, WXYZ and rows as ABCD. What about W with X? Sorry, W with A. Vertex W and S A.
One.
1. W with B.
One.
1,
W with C and D.
Zero.
0, 0.
And E again 0. What about X? X with A.
One.
1. X is endpoint of A. So 1. With B,
Zero.
0.
0. C and D 1, 1. Right? And E
Yes, ma'am. 0.
0. What about Y?
Ma'am, with C, D, and E, 1.
C, D,
In
and E corresponding to C, D, and E is 1. Again B, right? 1. At A, Y is more than point of A, right? That's why corresponding to A, the first entry will be 0, other 1, 1, 1. Right? 1. What about Z? Z. Z with
Ma'am,
A,
A, B,
0, 0, 0, right?
for
And
E
with
1.
E, it will give you 1. Understood? This is the
Yes,
matrix.
ma'am.
Now here also, uh, you can get the degrees by looking at the incidence matrix only. What is the degree of Y over here?
4.
From here also we got 4. What about this one? If you add all the corresponding row, all the elements, right? In the Y row, you will get degree. Okay. For X it is 3, and from here also 3. For W it is 2. Z it is 1. This is also the result that degree of ith vertex, that will be sum of all the entries in ith row, right? And same with this one. Okay. Now in MJ, will the diagonal entry, here no actual diagonal is present because this is not square matrix. Okay. So we cannot say A11, A12 will be diagonal. Yeah. If it is square matrix, then will always the diagonal entry will be 0? May not, right? That will depend on whether it is endpoint or not. Clear? So diagonal entry may not be 0. Is it symmetric? Is MG symmetric? Tell me. Can you say MG is symmetric? Anyone?
No, ma'am.
No. So in general, MG may not be symmetric. Diagonal entry may not be 0. AG, all the diagonal entry are 0 and symmetric. Okay. And AG is just coming from only vertex, right? That is vertex over here. So its order will be depending on order of the graph, but MG will depend on order and size both, right? It accounts for AG, that is all the vertices and edges, right? Any other doubt in this matrix? Finding MG and AG?
No, ma'am.
If no, we can start the next topic. Next topic is isomorphism. Before going to that topic, let me give you one graph. Have I done equality of graph? When you say two graphs are equal?
When vertex set and edge set are equal.
Yes. H and N, vertex and both are equal, then we see this one. Right?
Yes, sir.
Can you say these two graphs are equal?
Ma'am, 1 correspond to A, like that.
Correspond to. Is it same? No. So we cannot say these are equal, but we can say this is in form of corresponding. It is means we can define some correspondence between G and H, right? It
Yes,
is
ma'am.
similar to this one. This is a P4, right? One format of P4. This is another P4. So structurally they are different. You can redraw this graph, which will look like this graph, right? And this graph you can redraw to be same as G. Clear? So yeah, what you were saying, which will correspond to which vertex?
1 correspond to C.
One correspond to C, okay.
Ma'am, 3 correspond to D.
3 correspond to D, yes.
4 to A.
Yes, 4 to
A.
A. Why not B? Why not B? A, 4 correspond to A, 2 correspond to B.
B.
Right? So this correspondence means you have mapped the element from here to the element over here, right? You have defined a mapping. You have defined a function. Clear? This is a function, and from where to where you have defined it? What are these? 1, 2, 3, 4 for this graph? What are these?
Vertices. Vertexes.
Vertices. So from the vertex set of first graph, you can take this first, doesn't matter. So vertex set of this H graph to the vertex set of
G graph.
G, right? Yeah. Or you can also define vertex set from correspondence from G to H, right? That will be VG to VH, right? So 1 is going to C, means f of 1 is you have defined as C, right? Image of 1 under this function is C, f of 2 is your B, f of 3 is your D, right? And f of 4 is your E. Understood?
Yes, ma'am.
Is this graph, is this function 1, 1?
Yes, ma'am.
Yes, 1, 1. Is it onto?
Yes, ma'am.
Yes, onto. Why is it 1, 1 first?
Ma'am, every element of vertex of H correspond to every,
That
each element.
that is the definition of function. Na? All the elements should have some image, and that is unique image. That is coming from the function only. Why it is 1, 1?
Ma'am, every element in vertex set of G has one pre-image.
This is corresponding to onto.
Ma'am, one no.
Definition of onto, that all the element of G are occupied. That is from onto you are saying, not 1, 1. That is the definition of onto. Right?
Ma'am,
All the codomain part is occupied. That is actually onto, not 1, 1. How you tell
मैम
me?
मैम जैसे सी है तो इसका तो एक ही प्री इमेज है ना, वही मैं बोल रहा था कि हर एक एलिमेंट जो कि वी ऑफ जी सेट का है उसका एक प्री इमेज है.
हर एक एलिमेंट जो जी सेट से आ रहा है उसका एक प्री इमेज है. दैट इज onto. You are defined from here to here, na? So this is your domain. This is your codomain, right?
Yes, ma'am.
So all the element of codomain, every element of codomain have premise that is the definition of subjectivity, means onto. Anyone else? One. One. What is the definition of one function? We have done in DM. Come on.
Ma'am, every element from first V of H set
H.
has one image.
One image means different elements have different images.
Yes, ma'am.
Clear? Distinct image. Yeah. So that is, and here you can just see different element have different images, right? So that's why one. Okay. So you at the time of definition only you have defined this as one, right? So for onto you no need to write the definition that all the elements from codomain have pre-image in domain. You can see easily, that is you can analyze this one, that is from A to B. If you are defining some function and that is one with the condition that number of elements in A is equal to number of elements in B, that is the cardinality of A and B are same, then that one function becomes onto. Can you see it? Can you analyze it? One function with same number of element to same number of element becomes onto, right? One means different element have different images, and obviously each element will be corresponding to one, right? And number of element are same, that's why it become onto, right?
Yes, ma'am.
So this become onto. So number of that is order of the graphs are same, then it is, then one if you are defining one correspondence, then it will become onto as well. That means this is subjective, this is injective. If both, then what do we say that word? Yes,
Bijective.
bijective, right? So the function becomes bijective, right? The correspondence become bijective. Clear? Now one more thing.
Yes, ma'am.
Bijectivity is done. What about adjacency condition? Adjacency means to say you have defined this bijective from here to here, bijection from here, H to G. Where if you take any two element from H and if they are adjacent, then their images, their corresponding images are also adjacent. Is it happening?
Yes, ma'am.
Means 1 is going to C, right? 4 is going to A. You have defined like that. And this as means these are adjacent 1 and 4, and the corresponding C and A are also adjacent. And then
Yes, ma'am.
next, who is going to be, so 4 to corresponding images AB, and 2 3 BD, right? So by the while defining this function only, you have taken care of this adjacency condition. Okay,
Yes,
adjacency
ma'am.
means for all, for any UV, for all UV, U and V are element, the vertices. If U and V are adjacent in H, okay, adjacent in first graph, then this belongs to E set. It's H set of H then FU and FV. These should be adjacent in which graph? Second graph na? EG.
जी ग्राफ
And if you are taking G over here from VG to VS, then it will be VG to VS. And if their images are adjacent, because this is bisection, so they will be adjacent. And if they are non-adjacent, means to say here 1 and 3 are non-adjacent, then they will their images, corresponding images will be non-adjacent, right? And same is happening B with C. You can see B with C means 1 and 2. Their images are 1 and 2, right? And same is A and D, that is 3 and 4. Clear?
यस यस
So adjacency and non-adjacency. So what we have done, we had two graphs. Both are, we have shown that there exists a correspondence, one or you can just say bijection, bijective correspondence exists, which preserves adjacency and non-adjacency, right? So this F, this map, this correspondence, we say this is becoming isomorphism. This is isomorphism, and for any function to be isomorphism, these two conditions are must, right? Bijection plus adjacency. And if this is happening, if you are able to find F such that this is preserving adjacency condition and bijection, it is becoming the bijection, then you say these two graphs are structurally same. The structures are same, means you can redraw one graph to form another, means to say G is isomorphic to H. Clear? And this is the symbol of isomorphic. Is there any
यस मैम
doubt?
नो
Yes?
मैम
Okay. So two graphs, if they have same structure, same structural property, then you can redraw one graph to form another, right? Uh, these graph we may have drawn differently, but we can redraw it such that it will be same as the other one, right? For example, this form of K2 and this form of K2. These are both K2 not K4. These are both K4 na complete graph of order 4, but just drawn differently. But all the properties are same. Clear? All the structural property are same. Then these graph are isomorphic. Okay? If we can, these we will be saying that these graphs are isomorphic to each other if we define 1 1 2 means bijection map between the vertex set, which will preserve adjacency and non-adjacency relation. Okay?
मैम स्ट्रक्चरल प्रॉपर्टी मींस
Structural property means you can redraw the one structure to form the other one. Means all the properties will be different, will be same. That is the adjacency condition, or you can just say degree of corresponding vertex, or if one is bipartite, another will be bipartite. One is connected, the another will be connected. These property. Planarity is not a structural property, because in this one this is not planar. Sorry, plane. If you just say plane part, that this graph is not plane graph. This is plane graph. This plane property is not the structural property. Obviously, planar is, because plane is not the structural, na. Plane is the whatever the graph is, we look at that and we decide that whether it is plane or not, right? And planar is which can be redrawn. Okay. So except that plane thing,
Not audible, ma'am.
VH to VG, right? So in our case, this is VH to VG. Okay, isomorphism is what? A bijection F from VG to VH or VH to VG, such that this is your adjacency condition. If U and V are adjacent in G, UV belongs to EG means what? This is an H, right? In G means UV are adjacent in G. If and only if their images under this bijection are adjacent in the other graph. Okay, then this is known as isomorphism, and the corresponding graph are isomorphic. Is that clear? Can you give me one more isomorphism? One is this one. Any other isomorphism? Yes. Any other isomorphism?
Ma'am, one correspond to D.
One is going to D.
D.
Yes. One corresponding to D. Then,
Four
okay,
to
let me
D.
give
Three
you.
for
One is to D. Three is to C,
C.
right? And one to D, B. B and 4, right? 4 is with B. And 2 AC and 2 3. So 2 is with A. This will become similar way. This will become isomorphism and the graph are isomorphic, right? Now I'm defining again one more bijection. Now bijection, I'm not saying this is isomorphic or not. You need to define, you need to check whether it is isomorphic or not. And if yes, then prove it. If not, then why? Tell me why this is not isomorphic. One is going to C, 3 is going to D, sorry B, 2 is going to D, and 4 is going to A. Is it bijection?
yes, sir.
Is it 1 1 or 2? Yes, it is 1 1 or 2, right? Bijection.
Yes, sir.
What about can it become isomorphism?
No, ma'am.
No, why not?
Ma'am, because it does not satisfy adjacency.
Yes, adjacency condition is not preserving, right? It is not satisfying adjacency and non-adjacency. That's why it is not isomorphic. And that's you cannot give this function to show that these are isomorphic. Okay, either you can take this one or you can take this one. Clear?
Yes, ma'am.
Yeah, the same thing I have just proved here. This is P4, P4, and yeah, here I just take W goes to A, this one, X is going to D, Y corresponding to B, Z corresponding to A. Can you give me the other one, which will become the isomorphism?
W correspond to C. The
W
X
correspond to
correspond
C, X correspond to B,
Y
Y
correspond to D.
correspond to D, and Z correspond to A. Yes. So after defining that, you can just say different elements. This is 1 1, right? Different elements have different images. 1 1, right? And with the condition that both the sets have same cardinality, gives you this ontoness, right? Different to different and same cardinality. Then obviously all elements will be occupied. So bijection and adjacency condition preserve that we have taken care while defining only, right? So you can just write this definition for any two vertices, for all the vertices U and V. UV is an edge in Z if and only if FU, FV is an edge in H. Or you can say UV are adjacent in G if and only if their images are corresponding images are adjacent in H. And same is happening with non-adjacency. That is, if not adjacent, then their images are not adjacent, right? So that's this bijection plus this condition becomes your isomorphism, right? If it's F satisfied both condition, bijection 1, 1 or 2 and adjacency condition. Actually, this non-adjacency is coming from adjacency only, right? If adjacency is preserving means non-adjacency also preserving, right? So you can write both condition or you can write at least one, right? So bijection and preserves adjacency. That's why this becomes isomorphism. And whenever you are able to find some isomorphism, we are able to show some isomorphism exists between two graphs, then these graphs are said to be isomorphic, and the symbol of isomorphism is this one. Okay. In short, you can say if you are able to redraw the graph, the G graph, which will be looking same as H. Okay. Then G and H, there will be always existing some isomorphism. Okay, and these are isomorphic.
Ma'am, how to
G and
show
H will,
adjacency and non-adjacency?
yeah.
How to know it is a adjacency or not adjacency? Possesses adjacency.
See, this is you are just defining from here. Na adjacency means there is an edge between these vertices, right? W and X, and W correspond to, if your W correspond to C, if you are taking this one, and the adjacent vertex in while defining only we have taken care that this is going to X is going to B. Then W and X adjacent and their edge is adjacent, right?
Yes, ma'am. Yes, ma'am. Got it.
Okay. Means there is an edge between them. So that's all about it. This isomorphism. Yeah, if isomorphic, this I'll again come back to you in next class tomorrow. If isomorphic, G and H isomorphic, then the both the graph will be having many properties. Actually, in fact, all the properties same, right? Will be having same order. Number of vertices is same, right? Number of edges same. If one is connected, another have to be connected. Disconnected, another have to be disconnected. Both are bipartite at a time, non-bipartite at a time, right? If one is having some subgraph, the other should be having also the same subgraph, right? And same number of the same subgraph, same property, right? And if suppose G has n number of cycle, then H should have, right? That is number of subgraph, same type of subgraph. And degree, if the vertex degree, you can just see here, the corresponding vertex W is corresponding to C. So the degree of W over here is 1. Here is also 1. The corresponding vertices have same degree. X has degree 2. So X is going to be, P is also having degree 2. Y is having degree 2. D is also having degree 2. And Z degree 1, A 1, right?
Yes, ma'am.
And many more property. Okay.
Ma'am, these are structural properties.
Yeah. All the structural property means all the properties are same. You can just redraw to form the other graph. Okay. If isomorphic, then all the properties are same, right? Both for both the graphs. And if any one of these property fail, then that will not be isomorphic, right? That means if isomorphism is P condition, then this property is Q condition. If negation Q, then that will be negation P. Means either of these condition fail, then these will not be isomorphic. Okay. So actually, to show non-isomorphism is much easier than showing isomorphism. Okay. You need to just list one property that is failing. Okay. Suppose one graph is given as bipartite and another is not bipartite. Then the graph are not isomorphic, cannot be isomorphic. You cannot find the correspondence between them. Clear? So I hope it is clear. I'll come back to this topic again. Thank you all.
Thank you, ma'am.
Thank you, ma'am.
Good afternoon, all of you.
Good afternoon, ma'am.
Okay, so today we will talk about the communication process. Right?